This lesson is for Chapter 5, Section 4. Open up your books, please, to page 290, and open up your notebooks as well, and we'll get started. First thing, there are two main ways to solve exponential and logarithmic equations. One is to use the one-to-one property. The second is to use inverse properties that allow us to rewrite the problem and determine the answer. Here are the properties that you're going to be using to help you with that. These two are our one-to-one ones, and you'll recognize them from the earlier parts of this chapter. The second two are our inverse properties, and I want you to take a look at them real quick. We've been working with this one already. Okay, if the base of the log and the base of the exponent match, then the value of that problem or the value of that function is going to be whatever the exponent was. Number 4, this is a new one. If we have a to the log base a of x power, the value of that statement is also equal to x. Okay, so take a look at those two real well. They're going to be coming up in the exercises and in the problems for today. So solving each of these equations. All right, taking a look at the first one, 2 to the x power is equal to 215, or 5, whoops, I typed that wrong. That's supposed to say 512. Scratch that. Replace it with that. So you need to determine what power of 2, 512 is. And it ends up being 2 to the 9th power. So using our one-to-one property, we get an answer of 9. Okay, letter B, log base 6 of x is equal to 3. Using our equivalent exponential statement from the earlier part of the chapter, we can rewrite this one as x is equal to 6 to the y power. And the y power on here, what do we have? We have x is equal to 6 to the y, or to 6 to the 3, excuse me. Because there's your y value. And then you just have to evaluate 6 to the 3rd power, and we get 216. Okay, letter C. First thing I'm going to do on letter C is move 5 to the other side. So I end up with negative e to the x is equal to negative 5. Divide both sides by negative 1 and get rid of those negative signs. Now, with the e in there, we know we're looking with natural logs. So ln of e to the x is going to equal ln of 5. We know that the natural log of e to the x is x. That's from the earlier part of our chapter. So x is equal to ln of 5. Letter D, 9 to the x power is equal to 1/3. Now when I look at this one, I can see that a one-to-one is probably going to work here because I can rewrite a 9 as a power of 3, and I can also write 1/3 as a power of 3. So that's what I did first. 9 is 3 squared raised to the x power, and 1/3 is 3 to the negative 1. Simplify the left-hand side. You've got a power raised to a power. That has us multiplying those powers together. So I end up with 3 to the 2x is equal to 3 to the negative 1. I'm running out of room here. Sorry, guys. Stay with me. So 2x equals negative 1. X equals negative 1/2. So those aren't so bad to play around with. Take a look at checkpoint number 2. Solve each equation and approximate the result to 3 decimal places. All right, so we're going to do a little work here with these, and then you may have to use your calculator depending upon what you're looking at. With this first one here, I saw that we had e's as bases of our exponents on both sides, so I used one-to-one property right from the start. So if we have e to the 2x is equal to e to the x squared minus 8, 2x must equal x squared minus 8. I brought it all together on one side because I could see my quadratic. and I checked it to see if I could factor it. And if you use a -4 and a +2, you're able to factor, and so then that gives us 4 as a solution and -2 as a solution. So that one we should not need to use the calculator on. Letter B, we have 2 times 5 to the x power is equal to 32. I got rid of the 2 first. So dividing both sides by 2, I now have 5 to the x power is equal to 16. Okay, now with this one, I used sort of a one-to-one thought, and because I had 5 to the x power, I chose log base of 5. Okay, now look at this. This is where we start getting into a little bit new territory, working ourselves backwards. You guys see that if we had started with log base 5 of 5x equal to log base 5 of 16, we would have used our one-to-one property and gotten a 5 to the x equals 16 to work with. So all I did was I went backwards. And the reason for choosing the 5 as my base of my log was because my exponential part of this problem had a 5 to the x power. Okay, so now we have log base 5 of 5 to the x, which solves 2x. Okay, I'm using another one of my properties. And then log base 5 of 16 is still sitting here. Now, log base 5 of 16, that's not a log of 10. It's not a natural log. So we're going to use that ratio with our common logs. So I'm going to take, at this point, log 16 over log 5. Most of you guys like this one. Now I'm at the point where I have to punch it in the calculator. And if you do, you end up with 1.723. One caution before we get into too many more problems: don't approximate any of your values until the end of your answer. I have found that when I'm practicing these problems, if I end up rounding off things early in the problem, I can end up being off by a whole lot by the time I finally get through to the end. So hopefully you can get savvy enough with your calculator that you don't do things in too many chunks. You're able to do it in kind of one fluid entry, so that you're not doing a lot of rounding before you get to the very end. All right, checkpoint number 3. Solve e to the x, I did another typo. This is supposed to be e to the x power minus 7 equals 32. All right, so when I went at this one, can you make sure you change this, make sure that says e to the x. I got rid of the 7 first. So e to the x power is equal to 30. Now with e, I'm going to do that backwards thing again. E works with natural logs. So if I had had ln of e to the x and ln of 30, I would have gotten to e to the x equals 30 using 1-to-1. So again, I'm running it backwards. So I know that natural log of e to the x is equal to x. Okay, that's just a given statement. If you need to, think about your base. You can see these two matching bases here. We know we're going to get the power for an answer. Then ln of 30. At this point, you got to reach for your calculator again. Natural log of 30, 3.401. Checkpoint number 4. So solve 6 times 2 to the 2 plus 5 power plus 4 equals 11. Let's get rid of the 4 first. Then I went ahead and I got rid of the 6 as well. So I'm isolating my exponential part. Okay, if everybody can follow that. Now again, I'm going to do that 1-to-1 thing backwards. If I had 2 logs with the same base and these numbers as their x's, I'd have been able to get here with the 1-to-1. Now notice that your base of your exponent is a 2. So I'm going to go with log base 2 of 2 to the t plus 5 is equal then to log base 2 of this side as well. So once we get there, look at this side. I have matching 2's. I can simplify to t plus 5. Then I can get rid of my 5. Then, again, there's not a whole lot you can do with that log part. You're looking at another ratio to set up. So we're going to have log of 7/6. There's a question almost just like this on your quiz. There's your ratio, minus 5. Now is when you grab the calculator. Put in log of 7/6, divide it by log of 2, don't write that little. Log of 2, and then subtract 5. And you should come up roughly with negative 4.778. Next one. You're going to notice this video is full of just examples to do. I hope you guys like that. All right, now this one was a little bit of a stretch. We haven't seen anything like this before. This is going to take us back into our quadratics. Remember how quadratic equations had x squared terms? So let's pretend for a second that this was this problem instead and how we could factor it. Well, if you had e to the x times e to the x, that is e to the 2x, right? Because when we multiply same base exponents, we add the powers. X plus x is 2x. So this is actually a squared term, just like x squared was. So if that comes up, look toward factoring. We'd have that broken into an e to the x and an e to the x, and then a negative 4 and a negative 3 would fit into those spots. So now we're going to take each of these factors, e to the x minus 4, set it equal to 0. E to the x minus 3, set it equal to 0. And I'm going to have e to the x equals 4, which means I can go and reverse again my 1 to 1 and get natural log of both. Then x is equal to natural log of 4. Here's one of my answers. Punching that into the calculator, you'd have 1.386. Depends on what the directions ask. If it asks you for that decimal rounded to 3 places, punch it in. If it doesn't, I'd be just as satisfied taking it from that point. All right, so let's do the same thing with our other factor. Move 3 to the other side. Take natural log of both. So x is equal to ln of 3. And if you punch that one in, you're going to get 1.099. Checkpoint number 6. Solve the following logarithmic equations. All right, so if we have the natural log of x is equal to 2/3. Natural log again means e's. We have one piece set equal to another piece, so let's work our 1 to 1 backwards and make them powers of things. If I went and put that one and that one as powers of e, I would have been able to get that ln of x is equal to 2/3 from that. So I'm working it backwards. Now, if I have e to the ln of x, that's equal to x again. Then I have e to the 2/3, and there's nothing more I can do with that. Letter B. Log base 2 of 2x minus 3, log base 2 of x plus 4. That one's already set up for us to solve in a 1 to 1 fashion, so this one's kind of a simple one they gave us. Take that one and set it equal to that one. So moving the x over, I get x here. Moving the negative 3 to the other side, I get 7. And I am done with that one. Another one on this next page yet before we move on. Log of 4x is minus log of 12 plus x equals log base 2. Without the bases written in here, do you guys remember which log base that you're working with? It's those tens. So they do have matching bases on these logs. Okay, so remember what it is if you have a minus between them. Those two parts would have been a quotient. So go ahead and stack them. That didn't work very well. Stack them with 4x over 12 plus x. And then over here, we have that 2. Log 2, sorry. I can't condense that one. Okay. Yeah, I can. They were all the same base. They were all base 10. So they're all 1 to 1. We can just take the numbers away from the word log. All right, now we just solve. So I'm going to multiply both sides by 12 plus x. Why is my pen doing that? Sorry, guys. I'm getting little hiccups here. So 12x, or 12 plus x times 2 gives me 24 plus 2x. Okay, move 2x to the other side. And x is equal to 12. Okay, so keep looking for those same things that we were looking for in the first part of the chapter. Checkpoint number 7. Solve 7 plus 3 natural log of x is equal to 5 and approximate the result to 3 decimal places. All right, so I moved the 7 first. Then I got rid of the 3, so I divided both sides by 3. So the natural log of x is equal to negative 2/3. Here's where I turn both of those into powers of e again. So then I got to x is equal to e to the negative 2/3. Go ahead when it says in the directions to approximate it to the decimal and go on and put e to the negative 2/3 power in. I think one of the previous checkpoint ones, I just left it as that power of e because technically it didn't say to put it in decimal form. So if it asks you to, put it in. If it doesn't, you don't need to. You can just leave it. Checkpoint number 8, another variety of something that we could see. All right, so we have a 3 times log base 4 of 6x equals 9. The 3 out front we can get rid of. Okay, now I have log base 4 of 6x is equal to 3. So that's in my log ax equals y form. So I'm going to play around with that one again. I would rewrite that one as x equals a to the y. So 6x equals 64, and x would end up being 32 over 3. Okay. Checkpoint number 9. You invest $500 at an annual interest rate of 5.25%, compounded continuously. How long will it take your money to double? So we're into word problem land here. You were given a model or a formula or equation, function, whatever you want to call it, for continuous compounded interest back in, I don't know if it was section 2 or 3 anymore, but it looked like this. Remember that? So all we need to do is to fill in our stuff, and we're looking for how long it's going to take our money to double. So if you're looking for how long, we don't have time. So that must mean that we have values for everything else that we see. So A is the amount that you're looking for. Well, we want our money to double. So we're looking for it to reach $1,000. The principal or starting balance that we're working with is 500. The rate they give you is 0.0525, and then we have t. So we start to solve. I got rid of the 500 first. So 2 is equal to e to the 0.0525 t power. Then I did that natural log thing again. ln of 2 should equal ln of e to the 0.0525t. So then that number over there, or that power of e, is what I simplify natural log of e to. And I've got ln of 2 over here. If I'm solving for t, the last thing I need to do now is get that number off of it. So divide both sides. And this is where you have to grab your calculator. Punch in natural log of 2 and divide it by 0.0525. And you're going to get 13.2. So it's going to take us 13.2 years to double our money. Okay, so I didn't think that one was too bad of a story problem. So here you are for things that I'd like you to work with. And again, I've given you 7. I haven't given you problems and assigned them for a while. And it shows because a number of you didn't do too many with that last part of our chapter. So there's 7 of them here. If you have questions, you need to come see me. Otherwise, we will take up some of these again in class.